I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today, I am joined by Noah Redding, Director of Validation for Transportation at NI. Thank you for joining me today.
Yeah, thanks so much for having me, Sarah. Good to talk to you.
Good to speak with you as well. So today, we kind of wanted to learn a little bit more about NI's electric vehicle hardware-in-the-loop test architecture. Could you maybe provide a brief overview of that technology, or how it works, what benefits it offers?
Yeah, absolutely. Our electric vehicle HIL test architecture is essentially a customer-proven, higher-level starting point for modular test systems to validate software components for common electrified vehicle powertrain components like motors and inverters, for example. So the thing about electrified components is that they have some distinct characteristics that make them fundamentally different from more traditional combustion powertrains, which ultimately has a pretty significant impacts for validation and test systems and requirements that our customers are facing in the industry today. So for example, some of those components require simulation loops to actually have sub-microsecond loop rates. And if you look at traditional testing strategies and capabilities, and even the systems themselves, they're really going to fall flat meeting requirements. So in our case, we have a platform that's enabled with FPGA. And what that allows us to do is our platform combined with domain experts like one of our core partners, Opal RT, we can actually meet those requirements and provide a test system that gives a common starting point, which then our customers or other partners can then scale and modify easily because it's all based on a modular hardware and software-based platform.
Okay, all right. And so you kind of mentioned before about the powertrain components that it would be beneficial for. Is it all powertrain components in an electric vehicle, or is it only specific ones that it would work with? Or maybe delve into that a little bit about like maybe how this type of technology would work for developing an electric vehicle powertrain system?
Yeah, so two of the most common components that we're working with our customers on are really validating the control systems for motors and inverters. Now, because it's an architecture, the idea here is it can actually scale based on what customers want. So what we see is you have some people who work with that are really focused on the motor control. And so you can use the system to validate the control system for that. You can also do it if they're really focused on just the inverter. But we also have other people who are combining those together, perhaps in some sub-assemblies like an e-axle, or are really looking at testing kind of the whole powertrain collectively and everything together. So you can start to look at components with the motor and the inverter together, potentially with a battery that's there or a battery that's emulated. So that's really the beauty of having an architecture that can then scale from different types of validation and also different types of components.
Okay. And so is this a system that could work with any type of electric vehicle, or is there a specific types or market that you guys are that it's best suited for?
Yeah, so in general, there's a lot of commonality between the components across different types of electric vehicles, whether it's passenger cars or heavy equipment, construction equipment, trucks, SUVs, even scooters and motorcycles, for example. So lots of commonalities between those. But there are different careabouts and characteristics that go into depending upon the type of vehicle. So for example, if you think about how you spend time driving a car, you know, most of us may be in a car for maximum of 30 minutes at a time. So when you're really doing this lab-based simulation, you're trying to recreate real world scenarios as much as possible. So if you're looking for a passenger vehicle, you think that 30-minute max use case for the common drive experience, and you're testing profiles based on that. Versus if you've got construction equipment, for example, that has a totally different use case. So it's not that the components are different, but the way that users and drivers and operators interact with them are fundamentally different. So it's really just different profiles for how you would actually use it in the field.
Okay, all right. And so does NI see electric vehicle development advancing in the coming years, or use of these HIL test systems to help with those development of those vehicles? Or is there kind of any sort of insight you can provide on how you guys are seeing that all progress?
Yeah, absolutely. So we see hardware in the loop test and validation as an area that's going to continue to grow in importance. The value the value with hardware in the loop test is that it's lab-based simulation as opposed to road-based test or in the test tracks or actually
Mhm.
having physical prototypes of the vehicles. So the value that people get from that is you can reduce your cost of test because you don't have really expensive physical assets. You can create more scenarios and test the corner cases because you control the environment. You also have repeatable tests. So if you think about going out on a road or driving around town, for example, to
Mhm.
test, actually recreating the exact scenario, if you make some software changes, is really difficult with physical testing. But in simulation, you could do that more easily. Then you can
Right.
also accelerate testing because you can do testing in a lab, you can do faster testing, more testing in the same amount of time. So we certainly see hardware in the loop as an area that continues to grow in importance. And then for electric vehicles, I think there's no doubt that there's continued investment there. I mean, everywhere from you can read in the news every day of
Mhm.
some other additional investment, whether it's again with passenger vehicles or construction equipment or trucks or off highway. There's lots of investment there, and so our view is there's a lot of exciting technologies that are going into the vehicles, everything from increasing voltage and current levels to changing battery chemistries. Those are all going to have impacts on how the vehicle function, and they're going to need to really make sure that they're validating those systems appropriately. And so we're really looking to make sure that um, no matter where you are in the stage of development, whether it's early stage design, prototyping, HIL, or production, we want to make sure that our customers can actually use test as a competitive advantage.
All right. Well, I appreciate you taking the time to go over the technology with me today. Is there anything else you wanted to add or think our readers or audience should know about the technology?
Nothing specific other than please keep an eye out for the news because it's not hard to find updates and see what things are going on. It's a very exciting time, and
Mhm.
we're happy to be there with you.
All right. Well, great. Thank you again. I appreciate it.
Yeah, thanks so much, Sarah.